Today we will be going over Lab 3, Spaceships, Black Holes, and Orbits. So just as a general introduction, the purpose of this lab was to explore orbital trajectories and the effects of forces upon them. Some fundamental physics principles that you need to understand in order to really grasp the whole lab would be 1. Universal gravitation, 2. Momentum, and 3. Parallel and perpendicular force. And then on the right, you can see a table of contents of everything that will be covered in this video. Okay, so here's a breakdown of each of the physics principles you need to understand. For universal gravitational force, you know that the force is equal to a constant g, which is 6.7 times 10 to the negative 11, times the mass of each of those objects, and it's divided by the radius or the distance between them squared. Next, you'll see the momentum. You'll see the definition of momentum as mass times velocity. And you'll also see the definition of net force as a function of momentum. And then on the right, you'll see the parallel and perpendicular force equations, and it's important to note the similarities between those and the equation for general net force under momentum. So the purpose of the lab overall was to explore orbital trajectories and the impacts of forces upon them, as I said earlier. In part 1, we were tasked with finding the mass of a black hole by the use of glow script. In part 2, we were tasked with establishing an orbit in which a spaceship is affected by the gravitational pull of both a planet and its orbiting moon. This was also done in GlowScript. Here you can see the results. Um, for Model 1, the orange arrow represents the net force. The cyan represents the perpendicular component of the net force. And there is a magenta arrow which represents the parallel component of net force, but the parallel component goes in the direction of its orbit, and it is so small at that point that you cannot see it. You will also note that we found the mass of the black hole um, via glow script, and we took an average of all the different masses that were recorded, and it came back as 1.91325 times 10 to the 34th power kilograms. And then on Model 2, you can see that the spaceship is under the influence of both the planet and the moon's gravity. It doesn't collide with either of them for at least 700 hours. You know it's under the influence of both as it doesn't have one single trajectory. You can tell that each time it passes it, its trajectory changes. So here's Model 1. It's important to note that the momentum principle was utilized on line 169 in order to find the net force in line 172. And also Um, the parallel and perpendicular components of momentum were used to find the parallel and perpendicular components of net force. It's also important to note line 192, in which you can see that the mass of the black hole is equal to a seemingly random set of values, but that is actually the universal gravitation equation, which has been solved for m in order to get the mass of the black hole. So, what does this really mean? What's the difference between parallel and perpendicular momentum and net force? For all intents and purposes, it is the same. As you saw earlier, they have the same definition, and they're just the same thing. In fact, the components of net force are actually defined by the components of momentum. So here's Model 2. On the left, you can just see all of the variables being initialized. I skipped over that for Model 1. And then on the right side, you can see that the force of gravity is used to determine net force, and that both velocity and position update formulas are used. Um, the velocity and position update formulas were not included on this as they've been covered in each of the last slides, or each of the last lab reviews. So, here's the big what if question. What would you really have to take into account to predict the motion if all of this was in one system? And I would say you have to take in all all of the system into account, but that the black hole would dominate as its mass is so large. Thank you and have a nice day.